What's up, guys? Welcome back to the channel. Today on this video we'll be doing this function here by differentiating it from the first principle. So guys, if you haven't watched the videos where I differentiate the function from the first principle, I made a playlist that will appear at the end of this video, so you can watch this video till the end so that you can watch those videos. Basically, on those videos I differentiated expression of functions with x to the power of 1, x to the power of 2. Now on this one, which is going to be part 4 of the playlist, we'll be differentiating the one with x to the power of 3, as you can see here. Now if it's your first time coming to this channel or watching my videos, you can click on the playlist of this channel. I've made videos on trigonometry and limits as well. All right, so guys, you can pause and try to answer this question here. Let's see if we're gonna get the very same answer as the one that I'm going to get as I will be solving it. Right, now let's start. Remember guys, when you differentiate from the first principle, you need to use the following formula here, which is f of x prime. Remember, prime means differentiating, is equaling to f of x plus h minus f of x divided by h. Now the limits, h is approaching 0, so this is the formula that we must use. Remember guys, I've made a video about this formula. It's a first, in fact is part 1 of this playlist. I'm gonna put it on the icon there, so go and click that icon if you want to watch the video about what is f of x plus h and what is f of x, but I'm gonna try to explain it a little bit here on this video. So remember, the f of x is already given to us as a question, so we are fine, which is this part here. This part is the f of x, so we are fine, is given to us. You don't have to worry about that one. And then the one that we're supposed to get, the one that you're supposed to calculate, is f of x plus h. Now remember, when we find f of x plus h, let me just write it here. F of x plus h, wherever there is x, we must substitute by x plus h. So if we look at our function there, we have x cubed minus 2x. So wherever there is x, we put x plus h. Now this is going to be x plus h to the power of 3 minus 2, but wherever there is x, we put x plus h plus h. So this is our f of x plus h. But the thing about this f of x plus h, we have this function here, this expression here. Now we need to expand this, guys. We need to expand it. In order for us to expand this, we need to use the binomial theorem. Some of you, you would actually prefer to expand it using the traditional way. Remember, this is the power of 3, so you can say x plus h multiplied by x plus h plus multiply another x plus h. Some of you would prefer to use this one, the traditional way of expanding, but guys, this will take longer and you might make some mistakes there. So I would advise you to use the binomial theorem. Remember, when we use binomial theorem, we look at the power. If the power is 3 and above, rather use the binomial theorem. Now before you use the binomial theorem, you need to know the formula. Remember the formula for binomial theorem. Let me just write it here underneath. Yeah, let me just write it here underneath. Let me just write it what happened? And let me just write it here. Let's not forget 0 here. Let me write it here. Remember the binomial theorem, it goes like this: is x plus h to the power of n. Now I'm gonna write the formula just to make sure that when we substitute, we use this formula to refer to. Now we know that when we expand, it's gonna be, the formula is gonna be x to the power of n plus, that's the first term by the way, and then the second term is going to be n multiplied by x to the power of n minus 1 multiplied by h. That is the second term. The third term, we're going to say plus, and then we have n, and then it's n minus 1, and then we have n to the power of negative n minus negative 2, and then factorial 2. Let's not forget that h is also going to be the power of 2. That is the third term. The best way when you differentiate from the first principle, rather leave it to the fourth term. That is the safest term ever. If you go beyond, it's waste of time, because if you leave it to the fourth term, it's still gonna give you the answer even if you went above and beyond. So this one here, we can say n, where is we can say n, and then n minus 1, and then n minus 2. So let's not forget, we're gonna have x to the power of n minus 2, and then multiplied by h to the power of 2. All this divided by factorial 3, or 3 factorial. Guys, this formula here, I made a video explaining the binomial theorem formula, deriving it in fact. So you can go to the icon on top here, go and watch this video so that you can understand the binomial theorem. If you haven't watched it, go and watch it after this video, or you can watch it before we continue solving here. So let's continue. So we know that x is gonna be x when we expand, so we are fine with x. We know that h is gonna be also h. Wherever there is h, we're gonna put h there, we're gonna substitute h. And then we know that n, now if you look at our expression here, n is gonna be 3. There we go, n is gonna be 3. Remember, n is the power, so don't forget this. So this is very important. When you substitute on your binomial theorem expansion, it's gonna be easier. So let's start substituting. Remember, this is like this. In our case, it's gonna be x plus h to the power of 3. Remember, this is the one here. So let's continue. So we know that x to the power of n, x is x, and then n is gonna be 3. So that's the first term. The second term is gonna be, let me just sit in a very positive, comfortable position. And then the second term is gonna be n multiplied by x to the power of n minus 1 multiplied by h. So what is our n in this case? This is gonna be 3. And then we have x, and then what is our n? It's gonna be 3 minus 1 multiplied by h. Remember, h is h here, so we are fine. That is our second term. Now our third term is gonna look a bit complicated, but it's not really that difficult. We're gonna have n, there we go, our n, which is 3, then open bracket, we have 3, which is our n here, minus 1 over 2 factorial. So this is what you should put it on your calculator in order to get the answer. And then we multiply by n to the power of by x, I mean, to the power of n, which is 3 minus 2, and then h is gonna be h to the power of 2. Right, this is our third term. Now our fourth term, remember guys, I said to you, rather leave your answer in the fourth term. It's way simpler that way. Don't go beyond, because you're gonna still get the same answer when you expand, because of we are just differentiating from the first principles. So let's look at this. This is gonna be n. What is our n here? Our n is 3, and then open bracket, n minus 1, which is gonna be 3 minus 1, and then another open bracket, which is n minus 2, which is gonna be 3 minus 2, and then we say this is factorial what? 3, or 3 factorial. Guys, this is also, you put in a calculator to get the right answer there. Now let's continue. We have x to the power of n minus 3. This is 3, guys. Did I say this is supposed to be 3? Because this is the fourth term. This is 3. So it's supposed to be x, and then we have 3 minus 3 to the power of h, 3 to the to multiply by h to the power of 3. So this is your expansion. We just substituted. So the next step here, you need to calculate now. Let's calculate. So f of x plus, x plus h to the power of 3. So this is gonna be 3, x to the power of 3, and this is gonna be plus 3 x to the power of 3 minus 1 is going to be 2 multiplied by h. So this is going to be h. Now let's look at our third term. Now our third term, I told you guys that you only include the numbers only on your calculator. So on your calculator, you're going to type 3 or insert 3, and then open bracket, say 3 minus 1 close bracket, then you say divide by 2 factorial. So what are you going to get there? This is going to give us 3. So we know that x to the power of 3 minus 2 is going to be x to the power of 1, which is going to be x. Then we know that this is going to give us h to the power of 2. Now we say plus. Now the last term, we also do the same thing there. Now this time around, you're going to multiply by 3, multiply by open bracket, 3 minus 1 close bracket, and then we have another one, 3 minus 2 close bracket, and divide by the factorial. This time around is going to be 3 factorial. So what is the answer that you're going to get? The answer is going to be 1 multiplied by x to the power of 3 minus 3, which is going to give you x to the power of 0, x to the power of 0 multiplied by h to the power of 3. So this is your f, this is your x plus h to the power of 3 when we expand it. Now remember guys, let me just go up a bit. Remember guys, that this part here, it's actually this one here on our f of x plus h. It's only the first part there, so we need to do the other part here. So if we to write f of x plus h, let me just create more space a little bit here. If we do to write f of x plus h now in full, it's gonna be f of x plus h, right? And then this is gonna be, remember x plus h to the power of 3 is this whole expression there. So it's gonna be x cubed plus 3x squared h plus 3x to the power of multiplied by h to the power of 2, and then plus, remember this x to the power of 0 is 1 multiplied by h to the power of 3, which is gonna be h to the power of 3. And then now remember here we have negative 2, so we have to multiply by negative 2 throughout to get rid of the bracket. So let's do it. Minus negative 2 multiplied by x is going to be negative 2x, and then minus again negative 2 plus h is going to be negative 2h. So this right here guys, this is f of x plus h. Now this is the whole thing here. As you can see, this is the whole thing, f of x plus h. This is it right here. So let's continue guys, let's continue. Now we need to substitute our f of x plus h minus f of x to our formula. So we need to do it here on this formula here guys, on this formula here. So let's not forget, let's do it. This is gonna take a bit longer, but you have to brace the moment guys. So let's do it. So we know that f of x prime, we say limit, then we say h approaches 0. Let's do h here, approaches 0. So this is gonna be a very long line, but not a problem. So we're going to continue. So let's substitute f of x. Remember, f of x plus h is this long thing here, this long expression here. So let's do it. Let's not forget equaling sign here. So it's gonna be x cubed plus 3x squared h plus 3x h squared plus sorry about this, let me just remove it very quickly, plus where are we, plus h to the power of 3 minus 2x minus 2h. This is f of x plus h. So is this part here on our formula there. So let's not forget minus f of x. So if you go up there, guys, you will see what is f of x. Remember, f of x is actually 3, it's actually x to the power of 3 minus 2. So do not forget to put that in our bracket. So let's put this in our bracket. We're gonna have x to the power of 3 minus 2x. So that is our f of x. And then let's not forget all this is divided by h. So it looks very complex, but really it is not that complex. Let me just draw a line here so that people don't get confused, guys. This is when we were solving for f of x plus h, this part here. Let me separate it. Now from here, this part we are actually substituting. Now, like I said, guys, you can substitute here. Let's continue. This is the part where a lot of people make mistake. If you watch the first few videos, I didn't mention that. Make sure that when you minus f of x, remember f of x is the function that is given to us, which is x to the power of 3 minus 2x. Make sure everything is inside the bracket, because we have the subtraction sign here, which is going to affect whatever that is inside the bracket. So when you rewrite this, remember limits and try to be limits h approaches 0. Don't forget to write this, guys. Okay, forget to write this. And then we draw our line there again. Unfortunately, we have to rewrite this as it is. I know this may take longer, but it's very important for explanation purposes. Right, 3, and then we have x to the power of 2h plus 3x h squared plus h to the power of 3 minus 2x. Let me just make it like this, minus 2h. Now remember, we have a negative here, so we multiply by negative to remove the brackets. So if you remove the brackets, we're gonna have 3, we're gonna have negative x to the power of 3 plus, remember when you multiply by negative and negative, we're gonna be plus 2x, and all this is divided by h. Remember, guys, when we were doing the other problems, I did mention that on your numerator, the terms that has h, they must be remaining there. The ones that don't have h, they must cancel each other. Let's see if we did the right thing here, guys. So we know that the first term, which is x cubed, doesn't have h in them. It should be cancelling with one of the x cubed there, which is true. We have negative x cubed there. So this positive x cubed and this negative x cubed, they're going to cancel each other. They're going to give you 0, so they are out. So we go to the second term. The second term is 3x squared multiplied by h. It doesn't have to cancel because it doesn't have a like term. We have the third term, which is 3x plus h squared. It has h, so no like term. And we have h to the power of 3. It also doesn't have like term, but we do have negative 2x and positive 2x, so these ones, they're gonna cancel each other. Now this is what we are left with on top there on the numerator. Let me just create more space. Remember, guys, when you do the right thing here, the only thing that you must left with are the terms that have h in them. This is what I mean. Let me just write this very quickly. F of x limit, and then h approaches 0. This is what I mean, guys. I mean that the terms that are left here should have, like this one, x 3x squared multiplied by h. As you can see, it has h in them, right? and the other one which is gonna have 3x, and then it has h squared. Do you guys see it has h in them? And then the other one which is gonna be 2h as well, and the last one which is gonna be plus h cubed. So as you can see, all these 1 2 3 4, all these 4 terms that are remaining them, they are having h in there. So that's when you know that you did the right thing. If it so happen that there's no h in them and there is a term that is left there, you did something wrong. Go back to your equations and double check. Now what do we do here? Now the next step is to take out the common factor. Let's take out the common factor. Guys, remember to write limit h approaches 0 as long as we haven't substituted yet. So if we take out the common factor, our common factor on the numerator is going to be h. So if you take out the first term, is going to be left with 3x squared, and then the second term is going to be left with 3x and then h, and then the third term is going to be left with 2, and then the fourth term is going to be left with h to the power of 2, and then all this is divided by h. All right, if you were watching from the beginning, I did say that when you expand, there's no need for you to expand to the fourth term. Let me show you why. This h to the power of 3, guys, as you can see, this h to the power of 3 is from the fourth term. As you can see, when you take out h, this h to the power of 3 is gonna be left there, and as it is left there, the next step we're gonna substitute wherever h is with 0. So this is gonna be 0. Even this one here is also gonna be 0, which is the third term. So I would say if you don't really have time, leave it to the third term, or if you want to be sure, leave it to the fourth term. Don't go beyond that. You'll be wasting time, especially when we expand, guys. Okay, so when we expand, let's go back to our expansion. When we expand, this is our expansion here. Try not to go beyond the fourth term, guys. Okay, if you do want to be safe, just stop at the fourth term, which is this one. This h to the power of 3 is the one here that we have here, which is gonna be very, very useless when we continue. So if you want to, if you don't have enough time, I would say stop on the third term, which is safe as well. All right, so let's continue. So the next step, we drop off the limit and h approaching 0 thing there. We start substituting wherever there is h, we substitute by 0. So the first term we're gonna be left with 3x squared. The second term you're gonna be having 3x, then 0 where there is h. The third term it's only 2, so we are good, and the fourth term is gonna be h, which is gonna be 0 in this case, squared. Now if we continue, our answer here is gonna give us 3x squared. This is gonna be 0. Anything multiplied by 0 is gonna be 0, and then the third term is gonna be 3, is gonna be 2, I mean, so which is fine, and the last term is 0. So our final answer is gonna be 3x squared minus 2. I know this is a bit long, guys, but I hope you managed to follow through. What's so nice about this is that you can watch the video over and over again wherever you feel like you didn't understand me better, but also you can leave a comment on the comment section and ask a question if it so happened that you didn't understand a certain point. And if there is a shorter way of doing this, you can also comment on the comment section. Do not forget, guys, to like and subscribe if you find this video very, very useful. Share to your friends this method of differentiating from the first principle. And also, guys, at the end of this video there is a playlist of these videos where I actually differentiate from the first principle, so of other functions. So you can click on that playlist if you want to understand better, because I put those videos in a sequence order. Thank you very much, guys, for watching. Till next time, cheers.